Welcome to the dOrg Hot Seat. Today we have Codex Storage with Dmitry, who is the co-founder and tech lead of Codex Storage. Dmitry, it is a pleasure to have you here. And I'm going to start very straightforward. IPFS, Swarm, Arweave, Filecoin. Why do we need more decentralized storage projects?
Right. This is actually usually the first question we always get. How is it different? Why do you build another one? And it turns out it's not very straightforward to answer. If you start looking at all of these projects, they have vastly different goals and technical solutions, which lead to different set of trade-offs. When we started kind of looking at so our goal was to build sort of um, I guess, a storage layer for decentralized apps. We think that storage is one of the important sort of components to build, to be able to build decentralized applications, fully decentralized applications, compute being one of them, messaging being another, and then storage being another one. So when we kind of looked at all of the existing solutions and what they offered, we realized that they all had either different goals or some severe limitations that would prevent us from sort of realizing this vision of decentralized applications and building a decentralized stack. Yeah, I can give you details on how it's different from each of this.
Yeah, exactly. So let's dig into it. Like you said that you think that those projects are not ready for being built into production, the centralized applications. Um, what are the main or like the generic things that make them not ready, and how does Codex tackle this, and why is Codex ready for this? How does what are the trade-offs that Codex
Sure.
takes?
Yeah, I don't think that they're. It's not that they're not ready. It's that they had different goals, completely different goals. Like, for example, if you start looking at something like IPFS, IPFS is really not a storage network, right? It is more of a potentially content distribution network. And you could go even as far as saying that one of the goals of IPFS was to sort of an evolution of HTTP and kind of bringing some of the ideas from semantic web and whatnot into but it's not a storage project. And the reason why it's not a storage project, it's because it lacks any um, persistence guarantee. We call them durability guarantees, right? If you start going down the list of this other networks, Swarm has some durability guarantees, but it's actually not easily easy to determine how long the data is going to stay in the network exactly. So, like, if you're building if you need a reliable storage layer, you're going to have a hard time building on top of IPFS because you know if you want to persist your data for something like say 6 months, but you don't actually know whether it's going to stay there for 6 months or 5 months and a half. That's a problem if you're building an application. Filecoin had, they kind of set out to build a blockchain that stores data, I guess you could put it like that, and that led to a series of technical decisions and choices that ended up being building being a subpar storage mechanism. There's problems with how the data is being encoded in Filecoin. That's a very intensive process. It requires, the hardware requirements are very high. Retrieval is complicated. Arweave kind of claims that they have this permanent storage, but it's unclear how that mechanism actually works and whether it works or not. That's actually one of the problems with storage systems. It's understanding whether the mechanisms and how they've been put together actually work and give you what the project or the system claims it gives you. That's actually very hard to do. And Storage has some centralized components that, although it shares some of the intuitions that we used in Codex, it has some centralized components that you can't really call it a decentralized storage protocol or full decentralized storage network. So the requirements that we had was, well, we realized that a storage network should have, like, first and foremost, what makes a storage network is that its durability, right? So this property that is very well understood and very well known in centralized systems. Um, it, it's kind of missed in the centralized world, and it's also unclear how you get there, right? So how do you get this property of durability? And it's actually a very subtle property. There's a lot of layers to it. And so what we set out to do was to build a practical and reliable, durable storage layer with Codex.
Okay, so durability is kind of like the main goal here, and it seems to be complicated. Can you tell us a little bit more about how Codex achieves that property of durability?
Yeah. So what we found out when we started looking at this problem in general is that it is actually not well defined what will give you durability in decentralized storage, right? In decentralized storage networks. So one of the things we did was to kind of try to understand what how do you actually get there, what durability means in decentralized storage, and how do you get there. So we uh, we came up with this conceptual framework that sort of captures what are the elements and mechanisms that you need in order to get you to durability. We call this the decentralized durability engine. And what we found is that there are sort of like five mechanisms and properties that you need, um, and you need to combine them in a certain way to give you this property of durability. It's not magic. It's all pretty well grounded in research, and uh, a lot of these elements are present in centralized storage networks. But you kind of needed to evolve these notions into working in the decentralized settings, right? So what we found out is that you need redundancy, which is kind of obvious in storage systems, but then you need also a way of detecting uh, failures, corruption, things like that. And you need a way of repairing those failures. You also need to understand how the data is placed in the network such that failures are decorrelated and mitigated. And you need incentives, right? To essentially penalize bad behavior and reward good behavior. So those were kind of like the five elements we through a lot of iterations and thinking about this problem, we kind of came together with understanding that you actually need all of these elements and they have to be combined properly in order to give you this property of durability.
All right, so redundancy, so data is in multiple places, detecting when some of these places fail, and before it fails in all of the places where it becomes redundant, being able to repair, so this repairability, right?
Mhm.
Then understanding the topology of the places where the data is to decorrelate potential failures.
Yep.
And finally, penalties and rewards if you behave like you're meant to. Okay, perfect, nice. Um, cool. So how can users join the network as storage providers? You mentioned it before. Like for Filecoin, you need super hard requirements. For Swarm, what you need is you need some stake. You need to stake some BZZ token.
Mhm.
How is it for Codex?
Right. So right now we have a testnet, which is not incentivized, so you don't really need any stake. The hardware requirements are quite modest. All you need is a mid-range nuke or a mini PC with let's say 16 gigabytes of RAM and 4 to 8 cores, and you should be good to go, right? And then you can plug in as much storage as you'd like there. That's pretty much those are pretty much the requirements.
What is the node doing? Why does it need 16 gigabytes of RAM, for example?
Right. So it's doing some zero knowledge verification, right? So it's running some zero knowledge proofs over the data in order to understand whether yeah, the data that you claim you're storing is actually being stored properly. So that's where most of the processing power is going. There's also some erasure coding that happens on the client, but that doesn't touch the storage provider. Yeah.
So you use zero knowledge proofs in order to prove that you're actually the one that's storing
Yeah.
this.
So
Yeah.
yeah, we use a combination of zero knowledge proofs and erasure coding. So there's a very nice property that erasure coding has that allows you to sort of make sampling sublinear, where you can, if you erasure code a piece of data in a particular way, the amount of samples that you need to perform, it's drastically reduced. So we use a combination of zero knowledge and erasure coding.
So what is exactly is erasure coding?
It's a type of error correction that allows you to recover. Um, uh, it allows you to generate some um, extra data called parity data that is usually less than just making a copy, and it allows you to then recover the regional data from a combination of parity and regional data. So you can essentially lose a part of your data, um, completely lose it, or be it corrupted or lost, and then you can run some repair mechanism on top of it and recover it.
Is it similar to compression somehow?
Um, n- Not really. It actually expands your data that makes it larger instead of compressing it.
Mhm.
But it has some very nice properties where any sequence of parity data, which is the extra data that gets generated, and the regional data allows you to recover the data. So allows you to recover the regional data. So like it's more resilient than, for example, replication, which is just making a copy of something. And it's also more efficient in terms of storage. Right? You don't need to expand for by a factor of two, for example, to have two copies. You and
Mhm.
have the same sort of guarantees of resiliency.
Right. Yeah, super interesting. Erasure coding. I'll make sure to check that out. Um, we talked about how you can be a node operator, but you also mentioned that the main goal of Codex is to be the sort of the centralized storage base to build a centralized application. So how can a developer integrate storage on their application?
Yeah. So right now, just bear in mind that this we just launched our first alpha testnet, so things are still quite rough. If I may say so. So we have a REST API, a raw REST API that you can interact with, that the Codex node runs and exposes. And we also have an alpha version of a JavaScript SDK that developers can use to interact with it. Yeah.
All right. And what is sort of the distribution around it? Like how can or like how do you envision? I know it's probably not built, but like how do you envision this? Like you'd need to provide just like you need to provide an RPC for interacting with the chain on a decentralized application, for example. You'd need to provide a codex node as well to serve the content.
Yeah. So it could be both, either or, right? So there there will be HTTP gateways and RPC endpoints that can be interacted with. But probably the best way and the safest way to do it is to run a local Codex node and interact with it over the local REST API. Yeah.
Mm, if we were building like for websites, for example, or for web-based apps, do you think that's
Mhm.
feasible? Or how would that work? The
Um,
gateways, but
right. So eventually, we're planning on building um, essentially embedding Codex in browsers. So that's going to be something that we'll probably work on. Um, yeah, I'm talking about what's possible right now, but the vision is to actually have a full-fledged Codex node running in the browser at some point. Yeah, which will allow you to then
Nice.
serve and load anything that you'd like. Yeah.
Okay. Um, are there any proof of concept or any like applications that you've built on top of that testnet that people can just test or play
Yeah,
around with? Is there anything that we can see?
yeah, absolutely. So there's our POC sort of UI for the Codex, which allows you to upload, download data and make deals and rent and lease storage, which is at app.codex.storage, app.codex.storage. And that requires a local node that you can then connect to and manage that node and interact with it. And then there is a very nice, very fun app that was built, which is like a Q&A app called Kwaku. And it's Kwaku, Q-A-K-U dot app, A-P-P, which uses Waku, which is a messaging protocol also built by the Logos collective, and Codex as the storage backend. We actually demoed it live in Thailand, and that was a lot of fun.
Amazing, cool. Yeah, you mentioned you presented it in Thailand, and I think we saw a few things in Thailand, right? Like, sort of like the Institute of Free Technologies and all this, like the set of technologies. Um, Correct me if I'm wrong, but I think the whole logos ecosystem has Codex, has Nomos, and has Waku, and it's kind of like the response to what the Ethereum Trinity used to be, which was the Ethereum. It was Swarm for storage, and it was Whisper for communication, right? So that was not super effective back then. Only Ethereum has triumphed. Admittedly, Swarm is having a bit of a comeback now. But what failed? What went wrong with the original Trinity, and why did the IFT think that it would be a good idea to try again?
That's a great question. I don't know exactly what went wrong with the attempt by Ethereum to build the Trinity. I think it is crucial. Like this, three components are essential to sort of realize this vision of decentralized apps, which I think we all bought in when Ethereum came out. I think one of the reasons it's just sheer complexity of building all of this stuff, and Ethereum on its own, the consensus layer and the level of security and resiliency that we're trying to achieve with Ethereum, it's it's very demanding, right? Um, I think we had the right sort of talent at Status and now Logos to sort of tackle this problem specifically with messaging and storage, and we just gave it a go, and I think we're making some pretty good success. Like, yeah, we've made some progress.
Yeah, definitely. Um, okay, I want to put a last question, a bit of a spicy question, that has to do with uncensorability. I've seen some of your posts, and censorability seems to be like quite an important property on the design of Codex. Um, I would like to link that to what we've been seeing this week with Pump.fun and all of these absolutely dreadful streams on that were just meant to pump this shit tokens, right? Like there was violence, there was racism, there was self-harm, it was really the worst of the internet and of like the human race just put out there. Um, how like how does Codex, if anything, or if that goes onto the application layer, or like how does Codex approach content moderation?
Mhm. Um, so what our philosophy is that um, we're probably not the right ones to be moderating this. The protocol, we we have some tooling around. We could have some tooling, external tooling, not necessarily in protocol tooling, that could aid specific operators in addressing those issues. But the protocol itself, Codex, the way we built it, we are a neutral platform essentially. Yeah.
Hmm. So if I am a node operator, because I plan to be, right? If I'm a
Mhm.
node operator, and there's very, very unsavory content being hosted on my node, I might not want that. How,
Sure.
like, is there any chance right now that I can just remove that content?
Yes, you can opt out of from storing it. Um, Again, we take a little bit of a radical approach here, or a radical stance here. We are definitely not trying to. We're trying to be a neutral platform essentially, and I think the moderation tools that would moderate this would allow you to detect this sort of content and potentially remove it as a node operator that lives outside of the protocol. You can do it definitely once you realize that something you're starting something that you don't want to. But we, as the protocol, are not taking any action. In fact, what we do is that we protect the node operator from, um, uh, you know, from being exposed to the content it's storing. Essentially, we provide plausible deniability so that the node operator is protected legally from being prosecuted for whatever content is deemed illegal.
Yeah. Yeah, that's I think plausible deniability is crucial, especially when putting your own machine at the service of like basically random strangers on the internet.
Absolutely.
Um,
Yeah.
hmm. Okay, last questions. Last round. These questions come from Anita, and she would like to know what sort of is like the roadmap. When is mainnet coming?
So we're really trying to hit Q3 of next year with our mainnet, and yeah, it's going to be uh, yeah, we'd be very happy if we can make Q3 of next year.
All right. Is there a revenue model within, or how are you funded?
Right. Right now, we're being funded by the Logos Collective. Um, we don't have a specific revenue model worked out yet. The node operators uh, will be able to derive revenue from storing the content and serving this content or data. Uh, yeah, we're still figuring out you know our revenue model, but node operators definitely have a direct revenue model.
Gotcha. Okay, cool. Um, Last question from Anita would be, and I think you kind of hinted at it, like some applications on top that could do the content moderation, but like, but is there so everything seems to be AI powered right now.
Mhm.
Um, what are so try to pitch to a VC that's like an AI VC. What are the possible integrations uh, with Codex and AI?
Yeah, that's a great question. I think the simplest is training data and the models themselves can be stored on Codex. I think that is, for example, Hugging Face. It's I believe they're using something like 2.5 terabytes to store their AI related data, and Codex could very well be a layer for that. And I tend to think about of Codex as a decentralized hard drive. So pretty much anything you can think of doing with a hard drive, you can do with Codex, or should be able to do eventually with Codex. Um,
Mhm.
it's sort of a low level primitive, right? And I think this primitive on its own needs to exist in order to be able to power everything else that we want to build. um the specific use cases for, like, very narrow use cases like AI, it's a little harder to identify specifically how that's going to be integrated. I'm sure there's going to be crazy ways that that's going to be used, but just just thinking of Codex as a hard drive, I think it's a useful model. Yeah. Or
Yeah,
your S3 or something like that.
great framework.
Yeah.
Fantastic. I don't think we have any more questions from the DAO, from the members. So we can leave it here. But thank you very much, Dimitri. That was a very, very intense session, very intense dOrg conceit. We got lots of information, very much condensed. We appreciate your super fast replies. I think it was a really nice back and forth. I really enjoyed it. So
Thank you so much. It was great.
thank you very much. And we hope that the testnet will be amazing and that you will be hitting your Q3 ambitious milestones for mainnet.
Amazing. Thank you so much, guys. Thanks, everyone. Thanks for having me. It was great. Great questions.
Yeah, great answers. So perfect. Okay, see you, Dimitri.
All right.
Thank you.
See you.